we can find the magnitude of E by this. It is simple trigonometry. Can you solve that trigonometry and see if you are getting this answer? Let me know if you don't get it. Now, earlier I talked about the axis of dipole. This is the axis of dipole, this line. The results for potential and field are for any r theta. How about the point of interest being located on the axis itself? If point of interest is located on the axis, in that case, theta will be 0. Cos 0 is 1. Potential Kp by r square. Now you can also say, why can't theta be 180? You have got a valid point if you say that. If point of interest is here, cos 180 is minus 1 and potential will be minus Kp by r cube, r square, minus Kp by r square. That makes perfect sense. If point of interest is close to the negative charge, potential has got to be negative. What about the field? Field doesn't matter, cos square. So it will be twice Kp by r cube. And by the way, this is the magnitude. Magnitude will be twice Kp by r cube. For direction, let's see if it will matter or not, here or here. If point of interest is here, then the direction of field will be towards right side, isn't it? If point of interest is here, then again it will be right side. So doesn't really matter. Direction is same, magnitude is same. So that's interesting. Anywhere you take a point on the axis, field is always on the right side. Remember magnetic field lines for bar magnet? North pole, south pole. Inside also field lines are there. Inside they are from south to north. Isn't it exactly a similar thing? Right, 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 right. Another special case could be when theta is 90. Potential nothing. That makes perfect sense. If I take perpendicular bisector, well, locus of those points at which potential is 0, that locus must be this perpendicular bisector. Potential due to this will be cancelled by potential due to that. 0, 0, 0, 0. Will field be 0? No. Kp by r cube. Regarding the field's direction, magnitude is simple. You just put cos theta 0, kp by r cube. Regarding the direction, at any point on the perpendicular bisector, suppose I take this point. This fellow will repel the test charge. This fellow will attract the test charge. This will be the direction of the field. And that would be the case anywhere you go. Left, 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 left. And the dipole moment vector has right side direction. So we can say this field is anti-parallel to dipole moment vector. But will it be so here also? Yes, positive repulsion here, minus attraction here. Resultant of these two vectors, this only. So perpendicular bisector, any point you take, field will be leftwards. Axis, any point you take, field will be rightwards. Parallel to, rightwards means parallel to the dipole moment vector. Here it is anti-parallel. Any questions about special cases? Let me know. As you can see, this is an equilateral triangle. Question is, what is the dipole moment vector of this combination? If you are wondering that one can talk of dipole moment for just minus and plus, how can one talk of dipole moment for such a combination? Well, we can talk about dipole moment of water molecule, H2O. The whole molecule we can talk of. When there are several small p's in the system, then the big P for the system is the vector sum. So in water molecule there are two dipoles present. The two hydrogen-oxygen bonds, each one of them is a dipole. So small p and small p, then for the water molecule, big P will be vector sum of these two small p's. So in this question, just look out for dipoles. What you can do is that split this 2q, make it q plus q. Make it q plus q. So this q with minus q, that makes a dipole. This q with minus q makes a dipole. In fact, it resembles water a little bit. In water, oxygen has got minus 2q, hydrogens each plus q, plus q, plus q, minus 2q for water. Angle is different. So this q and minus q, vector P, this q and this minus q, vector P. The magnitudes of these two vectors are going to be the same. P is going to be QD for each dipole. Directions. Yes, just a moment. Joining the negative. Okay, in physics, negative to positive. In physics, direction is taken opposite. In chemistry, it is plus to minus. Yes, if you had a different point, then go ahead.
Sir, I was about to ask the same thing.
Same thing, okay. Now, these two vectors, we have to find their resultant. Can you tell me what is the angle between two small p's?
60.
Fine. Just simplify this. Regarding the direction, by the argument of symmetry, it has to be the perpendicular bisector, capital P. That means 30 degrees that way, or if you want to do it clockwise way, then it would be how much? 60 plus 13? No, 120 plus 30, 150. Clockwise way it will be from this line 150, or from here 30. Any questions? Let me know. The answer I have is magnitude QD by root 3. Direction I have told you. If you have anything to ask regarding this, let me know.
It is coming QD root 3.
Yes, sir.
QD root 3. Let me check. It should be QD root 3. Okay, anything else? Let me know. These things are given. Then what is the magnitude of the field at this point, which is just above plus Q? It's a straight line. This is 90-degree angle. This line makes 90-degree angle with this. This is A. This is A. There are so many ways to do this problem. If you just focus on point charges, something like Coulomb's law wave, then one vector E1, one vector E2, one vector E3. You superimpose these three vectors, you will get the answer. That's one way, but not very smart way. If you can make a dipole, then the question will become of one dipole and one isolated charge. That should be a smarter way to do it, especially if this information is given to you, then you should not miss on dipole. Now when I said many ways, you can take this as a dipole, this as isolated charge, or this as a dipole, this as the isolated charge. Which one is the smarter of the two? First, this dipole, or second, this dipole? For this point. First one. Let's see.
The second one.
Second one, I think, at the perpendicular bisector, this point for the second one is at the perpendicular bisector. That means what will be the direction of field due to these two? Left. I think second choice is a better choice. First choice means you take this dipole and that can be solved, but not very friendly way. So let's make this as a dipole. Field this. Isolated charge, field due to that. Space is less. These two are at 90 degrees. So easy to give the final answer. Isolated charge kq by d square. Dipole when theta is 90. That should be k times q into 2a then divided by r cube. R cube is how much? D cube. Then root of 1 plus 3 cos square theta. Cos theta is 0. That's it. But 2qa we have to take as p. Kp by d cube. Final E, magnitude only we want, will be this. So can you simplify it and see if you are getting this answer? Yes.
Can you explain, sir, why aren't we considering the first and the third one as well as the first and the second?
Can you repeat? Why are we not considering?
Dipoles, first and the third, as well as the first and the second.
If you are considering first and the third, and if you consider first and second also, then aren't you considering minus q charge 2 times? When you are finding field at a point, then field at a point is obtained by superposition principle. Effect of each charge accounted for only once. Effect of each charge accounted for only once. And then you take the vector sum of that. You can't give an extra weightage to one charge by counting that 2 times. So that won't be correct.
Fine, sir.
Any other? Yes. Any other question? Yes.
Sir, in the previous case, is R not equal to 2A?
What is not equal to 2A? R. It's given in the question. This distance is D. So R was what? Distance from this was the dipole we considered. From its center, distance of the point of interest. That's D only. Anything else?
Sir, is r the distance between the two dipoles?
In the formula of dipole, is r the distance between two charges? Let me clarify. In this formula, r is the distance from the center to the point of interest. That is r. And distance between charges, that is d. Anyway, d is not here. D is not here, so I don't need to write that. So that is r. Anything else? Now, what if you place dipole in some uniform electric field? When I say place dipole, it means that minus q and plus q charges won't change distance between them. You can just visualize a very light rod. Just visualize a very light rod. So that will keep them at the same distance all the time. So when this dipole is placed in a uniform electric field, then what happens? Imagine electric field is there everywhere in this whole region. Right side, right side, right side, everywhere. And with the same magnitude also. Then this fellow will experience QE force on the right side. This fellow will experience QE force on the left side. If I write vector notation, I will have to use minus. Magnitude wise, just QE, just QE. If you visualize this as a rod and take the system of these, then this system experiences no net force, no net external force it experiences. And if a system does not experience net external force, then the center of mass of the system cannot accelerate. Center of mass of the system is here. That won't accelerate. So it will just be there, center of mass. It won't move at all. But something else happens. This force applies torque about this point. Torque is perpendicular distance times this force. And this torque tries to turn this rod clockwise. This force also applies a torque about this point, force multiplied by perpendicular distance. Maybe this drawing will look better. Force, line of force extended, or then you drop a perpendicular from here. Likewise here, line of force extended, and then you drop a perpendicular from here. This torque also tries to turn it clockwise. So the two torques are not opposing, they are supporting. So that should give rise to spin. That should give rise to spin. So it will spin, but center of mass would not translate. It's not going to be like a rolling motion, but it's going to be like pure rotational motion, pure rotation. No translation, only rotation. So what is the total torque? That should be simple. Torque due to this plus torque due to that. Torque is R cross F. R cross F. R cross F plus R cross F. That will be the total torque vector. So it can be written as OA minus OB cross QE, which is same as OA plus BO cross QE, but BO plus OA. There some will be BA vectors. Direction of BA vector is from minus charge to plus charge. So is it not basically, I mean Q times BA vector, is it not basically vector P? Isn't it? Along P's direction. So it is QD, direction is also suitable. So it will be just P cross E. So that's about torque. That's a standard result. Torque equal to P cross E. Any questions? If you have, then let me know. Note that if dipole is placed in a non-uniform electric field, then what can we say? Then it will depend on the behavior of the field. But that rule which says that center of mass would not accelerate, that rule we cannot apply here. That would depend on the electric field. What is its direction at various points? What is its magnitude at various points? Now even if you say direction is same, magnitude may be different. So even if these two are parallel vectors or anti-parallel vectors, they may not cancel each other because their magnitudes may be different. So whatever we have discussed about center of mass, it is valid for uniform electric field. Potential energy is associated because of rotational motion. Work done is given by tau d theta. So when dipole is placed in uniform electric field, then we are now discussing potential energy associated with that. But torque is P cross E. So its magnitude is PE sine theta. I'm just writing the magnitudes, no vector sign, so no minus. Had the dipole been here, QE and QE would not have turned it. With respect to that position, let me consider theta angle. These two forces are trying to turn it clockwise. So actually, rotation is actually the torque is working against theta. Torque is working against theta. So in that case, I should be writing minus sign. Torque is working against theta. Just like we say vector F dot work done equal to vector F dot dr. In case of rotation, we have to see the sense. Is torque supporting theta? Is torque opposing theta? Accordingly, plus and minus signs would come. This is WC, conservative. We need to integrate. Again, the same story. You need some reference point where you say that potential energy is 0. The convention here is that at 90 degree, potential energy is chosen as 0. Again, that can be changed if you want. It is just convention. If we are choosing so, if we don't, something else can be chosen. Or let me write first general. Maybe I can write theta 1 to theta 2 or maybe theta naught to theta. And likewise u naught to u. So u minus u naught, P outside, P is anyway constant. P will be constant because we are considering it as constant. Integral of sine theta. There we are. That's a general result. Now if you want to take some referral point which is normally taken at 90, in that case this is the formula. U at any theta, which is dot product of vector P and vector E. This result is only valid if this convention is followed. Otherwise, this is the thing that you need to use. For any reference point, this will work. So one result cross product, other result dot product. Any questions? Let me know. What do you think?
A.
A. Yes.
Sir, when the dipole is placed in the equatorial manner, then what will be the dipole moment?
How is that related to this question? And by the
Sir,
way, dipole moment has nothing to do with the position. Potential and field, they have to do with which point are you talking about. Dipole moment, how you place minus and plus charges, like this, like that, how does it matter?
Sir, I mean to say force, sir, not dipole moment.
Force is always zero, always, no matter how you place it. Look at this. No matter how you place it, the two vectors are always going to be opposite. Of course, that is when field is uniform. If field is not uniform, that I also have discussed here, then nothing can be said. It will all depend on the behavior of the field. Will they cancel these two or will they won't cancel? It will completely depend on the behavior of the field. That's all, 5 options, and and more than one may be correct. Yes, any clarification?
So in the option F, sir, which thing depends, sir, the torque or the force?
The answer. The options A, B, C, D, whatever you are choosing for force and torque. The options are for force and torque. These will depend if the charge is positive or negative. You cannot answer. It means basically that you cannot answer any of these questions. The answer will depend if the point charge is positive or negative. Any other clarification? Alright. So more than one may be correct. That's your assignment. We stop now.